We're going to continue with section 1.2, so we're going to be on page 2 of the notes sheet. So this gives us cause to review the couple definitions that we had. So if you remember, we talked about what's called a relation. A relationship is just short for, a relation is just short for relationship. And in math, we denote a relationship by using ordered pairs. And then we talked about what was called a function. A function's a special kind of relation. Does anyone remember? You can probably just read it from your note sheet. What is specific about a function? Bam, very nice. Each x value gets exactly one y value. Another way of thinking about that and visualizing it is that each x, if you go down the list, each x is listed one time. And we did 3 examples, and then we talked about domain and range. So here's the next example. This is example 5. This will give us a chance to pick up where we left off. So the first type of relation that we looked at on page 1, we saw sets of actual ordered pairs listed out. But there's other ways in math that you'll see the relations given to you. This next one is just a table. There's really no difference in this problem and the previous ones. So this is just using a table to list out our points, meaning the relationship. And so we see that 8 is related to 9, -6 is related to 2, 3 is related to -4, 11 is related to 2, 5 is 0. All right, so question, is this a function or not a function? Why is this a function? Each x is listed once, or each x corresponds to only to one y value. So this is a function. Then we talked about the concept of what a domain is and what a range is. So just making sure we're familiar with this terminology. Remind me, what's the domain of a relation or a function? It's the x values. So I use some squigglies here, and I'm just going to list the x values. Now, it's preferred to write them in number order, and you don't write duplicates. But if you don't write them in number order, I won't mark it wrong. It just gives me a headache, that's all. So here we go, -6 and 3 and 5 and 8. And 11. That is our domain. And then the range of this, what does the range refer to? Y values. Okay, fantastic. And so same thing, I'm going to put the -4, the 0, the 2. I've got 2 2s. Okay, that's fine. I'm just going to write it once, and then 9. Okay, that's about where we were in section 1.2 before we clicked off the last video. Do we have any questions about that? Anything I need to go over again? Then what I'd like you to do, please, is exercise 6 right next to it. Do the same thing, function or not a function, and regardless, write down what the domain and the range are, please. All right, here goes. Looking at my table, here's my relation. Is this one a function or not a function? It's not a function. Why? There's 2 -3s. -3 corresponds to 2 y values, 10 and -9. That violates our definition, so it is not a function. Okay, so the domain is the set of x values. So I'm hoping you wrote down -3, 4, and 7. And then the range is the y values, so -9, -1, 3, 6, 10. Still doing okay? The next example is just another way that you'll see a relationship given to you. Example 6 is what's called a mapping. Okay, so you use kind of 2 clouds. I've used ovals to represent your values, and then you use arrows to represent the relationship. So this is example 6. My two bubbles. Okay, so according to this mapping, maybe you have, maybe you haven't seen one of these before. What value does 2 correspond to? 7 corresponds to 5, 13 corresponds to, yeah, it's not too big of a deal. We could write this as ordered pairs. That's not what I want to do. I just want to know, is this a function or not a function? So what would you propose? It is a function. Each x has one arrow leaving it, okay? So meaning it corresponds to one y value. So this is a function. I'm going to leave it to you on the next problem to write down the domain and range. I don't think that's too difficult of a concept. I don't want to overdo it. So with that in mind, exercise 7, function or not a function, and then what's the domain and the range? All right, my first question, function or not a function? Which x value violates my definition of function? Yeah, -2 has 2 arrows leaving it. -2 corresponds to 0. -2 also corresponds to 1. Are you gathering what a function is? Are we doing all right? I know this is sometimes a difficult thing to get into the brain. I totally understand. I had to learn all this a long, long time ago in a galaxy far, far away. So I just want to make sure we're getting solid on this because our whole semester is the algebra of functions. Okay, so getting this concept is good. So this is not. And then the domain is the x values. And the range is the y values. Fantastic. Okay, so now flip to page 3. We're getting a little closer to what we're going to see more and more of. We're going to transition from relations being given to us as either sets of ordered pairs or tables or mappings. We're going to see a lot of graphs this semester. So in example 7, now on example 7, you don't see any points because I am not that good with Microsoft Word to be able to do that. So we're going to fill those in ourselves. So here's my Cartesian coordinates, very skilled. And so here's the first example that we're going to do. I'm just going to put, there's nothing special about 3 or 4 points. I just don't want the examples to be too long. Okay, so don't infer any sort of significance to how many points we're doing. So on your graph, go ahead and mark a point at -3 and 2. And then put a point at 0 and -4. And then we'll just go with one more, 2 and 5. So while I am drawing the graph for exercise 8, do me this favor with this one. Same 2 questions. Function or not a function, and what's the domain and the range? All right, so for exercise 7, what do you propose? Function or not a function? It is a function. And I've listed the ordered pairs along with the points just so that we're all on the same page here. But -3 only has one y value, 0 has one y value, 2 has one y value. This is a function. And then the domain and the range, again, I don't gather that this is the hard part. We're not going to do the domain and the range of the next example. But the domain of this is -3, 0, and 2. So I just go along the x-axis and I look at where are their points. And then the range, I go along the y-axis, same thing, -4 to 5. 5. We're doing all right. Am I going too fast? Anybody got a question? All right, so this one, exercise 8. I've put 5 points on there. -5, 3, -5, -2, -2, 1, 0, -1, and then 6, 2, 6, -5. So same 2 questions. I'm going to give you 30 seconds. Is this a function or is this not a function? And then what? Don't worry about the domain and the range. So just one question. Is this a function or not a function? All right, so what do you think? Function or not a function? Not a function. Why is it not a function? -5 has 2 y values. 6 has 2 y values. It only has to fail once, but I wanted to point out both. Now, the reason I mentioned this is because we are going to be looking at a lot of graphs. So this example helps us devise a quick and easy test to determine if a graph is a function. And so here is the test. This is called the vertical line test. Probably, if you've taken some algebra before, you might have seen this. The vertical line test. Now remember, the equation of a vertical line, vertical means up and down, straight up and down. The equation of any vertical line is x equal to a number. Basically, the vertical line represents the x value. So if you can take a vertical line and it passes through, as you pass the vertical line over your graph, if it always hits one place, you've got yourself a function. If a vertical line ever hits in more than one place, it's not a function. Now, if I was close to my office, I could run back and get my yardstick, which I don't have because I'm not that bright. So we're going to use this piece of paper as my vertical line. So here we go. So notice when I pass the vertical line, how many times does this vertical line hit the graph? Twice. What that means is for this x value represented by the vertical line, there are 2 y values. There's a y value up here, there's a y value down there. And that's why the vertical line test quickly can tell us if a graph is a function or not a function. Okay, so we are now going to use that vertical line test on these next examples, which I haven't written up here, so that was kind of a fail. Oh, look, they're not there. Okay, so the example 8 is a circle. Not too bad. You will get to know over the course of this semester that I can't draw. First math class I ever taught, I taught a Calculus 3 class when I was in college. I had to cancel the first day because I couldn't draw 3-dimensional figures on the board, and it was an epic fail. So I'm no better. Okay, this is supposed to be an oval. That's why you've got the printouts. Okay, so the first question here is this a function or not? So look at my circle. Is the circle a function? Yes or no? Vertical line test, okay? And just if you want to draw some dotted vertical lines to prove this to yourself. In fact, I'm going to take my own advice. Oh, look, that vertical line goes through the graph in 2 places. That means that for whatever x value that red line represents, there's 2 y values. So this is not a function. Now, the more interesting question for us, and this is why we talked about interval notation at the beginning of section 1.2. At some point, we talked about interval notation. I think at the beginning of this section, if I'm remembering right. What's the domain and the range? Now, I don't want you to fall into this trap. It's a trap that's easy to fall into, and a lot of students do. Please notice the difference between this graph and this graph. How many points are on this graph right here? Yeah, there's 6 points on this graph. So my domain, if I was to list my domain and range, they would be a distinct list, right? You'd have 5 or 6 or maybe 4 values that you would list out because there's only 6 points. How many points are represented on this graph? there's an infinite number of points. Okay, they're all just scrunched really together. So I cannot make a list. So please don't try. Sometimes on tests, I get students who will make a few dots on here, and then they'll go ahead and make a list. Okay, there is an infinite number of points. So what we have to do is use interval notation in order to do my domain and range. So the domain, remember the definition of domain is my x values. So we look left and right. And if you remember from last time, interval notation is always the same form. We put the lower bound or the lower limit and the upper bound, the upper limit, and then we put things on the ends. So looking left and right, my x values. What's the lowest x value that you can see on your paper? Yeah, there's no tricks or gimmicks. I do my best to make sure it's going right through that. What is the largest x value? 5. Everybody see that? Then, since the graph does go through those points, what am I going to put on each end? I'm going to put brackets because the graph goes through it. Fantastic. How about the range when I look up and down now? The range or the y values. So when I look down, what's the lowest y value? Yes, circles are not always super fun. What's the largest? 5, and again, there we go. All right, so this is an oval, poorly drawn. It looks much better on your sheet. So same thing. Is it a function or not a function? And then what's the domain and the range? All right, so for the oval, what was your answer to the first question? Is this a function or not a function? Okay, again, when I draw a vertical line, it only has to fail one time. This oval would fail a lot of times because you would have 2 y values for every x value. So this is not a function. The domain, what's the lowest x value? -5. What is the largest x value? Yep. And then we're going to use brackets again because it goes through that. And then the range, by the way, I would never try to trick you on a test or anything. Sometimes when I draw, I'm not perfect, but there's never going to be a time when I ask you from a graph like this that it's -4.95 or something like that. That's bad math teaching. Okay, so that there's no tricks. So if you were like, I couldn't tell exactly, just assume. Okay, I'm not trying to trick you. I want you to enjoy this class. Okay, what's the lowest y value that we have? -2. What's the largest y value? Yep, and then some brackets. Okay, so I'm going to give you the next one. I want you to do the best you can. If the domain and range, if you struggle with it, it's okay. That struggling means you're learning. So this example right here, it is example 9. Same 2 questions. What is it, a function or not a function? And then what's the domain and the range? Okay, first question, function or not a function? Function. Yeah, so you can imagine if you had your driver's license or something, you can keep drawing vertical lines for x values, and you notice every vertical line that I draw goes through the graph only a single time. Okay, so that's fantastic. That is why this is a function. Okay, so maybe if you have your credit card or something and you slide it across, if you struggled on that, that will help you to see it. So this is a function. Now the domain and the range might have been a little harder because there's not necessarily always starting and stopping points. So let's look at the domain. Remember, what do arrows on the end mean? Keeps going. If they were dots, this would be a different story. Okay, how far left is this graph going to go? Negative infinity. The arrow means it's just going to keep going in this general direction. What's the furthest to the right that this is going to go? Positive infinity. Fantastic. And remember, at infinity, we always put a parenthesis every time, every day. Sorry for those of you watching on the video. Let me be a better math instructor. All messed up. There we go. All right, the range. What's the furthest down this goes? -3. And what's the furthest up this is going to go? Now, while I put a parenthesis at the infinity part, what am I going to put at the -3 part? A bracket, because it actually goes through that point. Fantastic. Same thing with this one. This is the last graph we're going to look at. It's these both are called parabolas. This one was a function. We'll see if this one was. It's facing to the left. Give it a try. Function or not a function, domain and range. All right, so the parabola laying on its side, function or not a function? Perfect. I'm sure all of you have seen, oh, look at that vertical line. That means that x value hits two different y values, so that's why it is not a function. And then my domain and my range. The domain, left and right. So how far left does this one go? Yes, it does. How far right? Stops at 5. And then the range, how far down is this going to go? Yeah, just going to keep sliding downhill. How far up? We will use interval notation every day. So when you go through your homework, make sure you're comfortable with that. Okay, we're going to use it in our next section that we get to. I don't know if we'll get to it today or if that's going to be on Wednesday, but interval notation is part of that. Part of just about every section we do. Okay, any questions up to this point? How are we doing? All right, last page. At the top of the last page, example 10 says, for the function in example 4, I have relisted right here. You can flip back in your packet. This is A, which we determined on Wednesday was a function. For the function of example 4, find these function values. So the next skill that we're going to do, we've now learned to discern whether something's a function or not. We are now going to determine what function values are. So for this right here, I want to find the function value at 3. I want to find the function value at 7, and then the function value at 11. Now, I'm guessing that you've had some cursory experience with function notation, but in case you have not, okay, what does this value in here represent? Where do we get that from? It's an x value. What this function notation says is when I put in this x, this is like the input, what value out do I get from the function? Meaning, what y value corresponds to this x value? Okay, that's what function notation is telling me. So, looking at the way that this function's been defined, what is the value that corresponds to the x value 3? Perfect. There's the ordered pair. Now, notation is important. It means understanding sometimes. Do not write the whole ordered pair here. That's not the answer. The answer to this is simply 5, the y value. What's the function value at 7? Perfect, well said. What's the function value at 11? This function does not define a relationship between an x value 11 and anything else. So what we write is not defined or undefined, either way. So please do the same thing for exercise 11. It has you refer to this table from example 5. All right, so for this function, we determined it was a function earlier. So what we want to know is what's the function value at 7? And you came up with... I'm sorry, I'm on the wrong problem. Hang on. I'll get my act together someday, don't worry. All right, so first one is what's the function value at -6? That's better. Now we're on the proper problem. It's 2. And then what's the function value at 11? It is 2 as well. That's great. So exercise 12 says for the function in example 6. Oh, so I wrote the wrong one. That's okay. So this is number 6. It's this mapping right here. If you turn back in your packet. So go ahead and answer the questions for this one. All right, so according to this mapping, what's the function value that goes along with 7? Perfect. The function value that goes along with -8. Fantastic. Our final one of these, and then we have one more little thing to do for this section, and we're done with section 1.2. The parabola we determined was a function. So using the graph that you have, what is the function value at -2? So take a moment and look at that and see what you come up with. Again, assume it's obvious. I'm not trying to trick you there. So when I look at this graph at the x value -2, what's the y value that goes along with that x value? 0. Yeah, it's right here. It goes right through -2, 0. So there's my output. All right, last but not least, probably the slightly more common way that you will deduce function values is to actually be given a function, and you'll have to plug that value in. So this now becomes arithmetic, order of operations, that sort of thing. So example 11, my last example from this section, defines this function. So this notation says I have a function of the variable x. That doesn't always have to be that way. If you're taking an economics class, you might have a function of t for time or p for price, things like that. The letters are immaterial. It's the concept that is not going to change. So this is a function of the variable x, and it's defined by 5 minus 2x. Nice little linear function. So I'm going to find f of 4, and then I'm going to have you do the other part to this problem. So just to make me happy, please. When I see a 4 here, what am I going to do with that 4 to find the function value? Yeah, I'm going to plug it in for x. Now, this isn't too complicated a function. You could probably do that in your head. But what I would encourage you to do, because when we're dealing with functions that have exponents and fractions and all negatives and things like that, the first step I would encourage you to do is to first just put, instead of an x, put some parentheses, and then plug your number in right there. And like I said, on this linear function, that's probably not super necessary for you. I'm assuming you're pretty decent at arithmetic, but for more complicated ones, that might be a good thing to do. Okay, so order of operations, multiplication comes before subtraction. So I have -2 times 4 is -8, and then 5 minus 8 is -3. So the function value at 4 is -3. Now, when you go through your homework, you might be asked this sort of question. Okay, now that I know that, what ordered pair is on the graph? What's the x value of the ordered pair? What's the y value of the ordered pair? Just trying to reinforce that relationship between our graphs and our functions and our equations. All right, so the other part to this example, or to example 11, please do the function value at -5 using the same function right here. All right, so I'm going to plug in -5. So I've got 5 minus 2, and in parentheses, I'm going to put -5. Order of operations, multiplication comes before subtraction. So -2 times -5 is +10. And then 5 plus 10 is 15. All right, we've got two final problems from this section. The first of those two is this is the last function we're going to be considering. It is 3x minus 2x squared. Firstly, I would like you to find out what g of 2 is, please. So the first thing I did was I followed my own advice, and I use some parentheses wherever there was an x, so that I could just fill in the parentheses with the value. So in this case, that is 2. And so order of operations says exponents come before everything else. So I've got 2 squared, that becomes 4. Now I'm going to do that multiplication. 3 times 2 is 6. -2 times 4 is -8. And so that means my function value, this function is labeled g instead of f, just for some variety, so we can have some fun. And 6 minus 8 is -2. Last problem from this section, and then we are done with section 1.2, is for this same function, please find out the value of g at -3. Just want to make sure that we develop some confidence when we've got negatives and powers and all that good stuff going on. All right, so just please be super careful when you're plugging in a negative. The negative is part of what I'm plugging in, so anything I do with the 3, I'm also doing with the negative. So the reason I mentioned that is probably the most common mistake I will see on tests if I give a problem like this, is forgetting to also square the negative, kind of leaving the negative outside of the squaring. So -3 times -3, that is 9. So I have -9 and then -18. So the function value at -3 is -27. All right, that's going to wrap up this section. Does anyone have any questions that I did not do a good job addressing, anything like that?